All right, so we're meeting here on day 2 of Unit 6. We're talking about geometric proofs. Woo! I know, you're super excited. All right, so as with any proof, we are always going to start with our given. So in this case, our given is that AB is congruent to CD. That's just given to us. It's given to us in our given, and it's also given in our picture. Now what we're trying to prove here is that AC is congruent to BD. Some of you already see how we're going to go about doing this. Other of you, maybe not so much. So the first thing I want to do is create the line AC, because right now it doesn't exist. So let's get that existing, because that will probably help. So let's say if I want the line AC, that's made up of AB plus BC. And that's going to be the whole line AC. Now, what's the thing that tells me I can do that? Well, the property is the segment addition postulate, which says that if we take a tiny piece of a line and we add it to another piece of the same line, then we get the bigger line. Yay! We can do the same thing to get BD. We can say that BC plus CD equals BD, which again is the segment addition postulate. So I'm just going to leave those in the same part. Now, if I go to this next step, I now need to somehow get that AC is congruent to BC. Well, I know that if I add the same thing to both sides, that it remains equal. So if I take AB and I add BC to that side, and I know that's equal to CD, but then I've also got to add BC to this side. Well, if I add something to both sides, that is called the addition property of equality. Very cool. Now, I notice that now I've got AB plus BC. Well, I see that earlier, AB plus BC equals AC. So I'm just going to replace this with AC. And I'm going to replace this CD plus BC with BC plus CD, because it's the same thing, just in a slightly different order. You just flip the two. So we can say that AC is equal to BC, and this was by the substitution property, because we substituted in what we knew to be true. Substitution. I missed a TU. Dang it. Substitution. There we go. Look at us go. All right, now it says equals and it doesn't say congruent yet. So we need to get to that congruence. Well, I know if they're equal, by the definition of congruence, that means that they are also congruent. So AC is going to be congruent to, shouldn't that be BD? Yeah, it should be BD. AC is congruent to BD. Fantastic. And that is by the definition of congruence. Because by the definition of congruence, if their measurements are equal, that means that they are also congruent. All right. So let's go to this next proof. We're going to do this one together, and then you guys are going to do a ton by yourself, and then we'll do one more together. So the proof of vertical angle theorem. So the first thing this gives me, I can always start with my given, is that angle ABC and angle EBD are vertical angles. And the reason is given. Now that doesn't actually give me a lot of information, not yet anyway. After we prove this, knowing that they're vertical angles will give me quite a bit of information, and it'll be very exciting. So now, I know that this is a vertical angle with this. Fantastic. Tells me nothing. But what if we add in this angle right here? So that CBD is a linear pair with the two angles that are vertical angles. That might come in handy. So let's say that I know if they're a linear pair, that means that they are supplementary. So I know that the angle ABC and angle CBD are supplementary. The reason that they are supplementary is because these are a linear pair. And linear pairs are supplementary. Okay, And then we also have the other linear pair. So the angle EBD and angle CBD are also supplementary. Now there's this very cool postulate that is in our notes in 6.0 that says if two angles are supplementary to the same angle, then they have to be congruent to each other. So that means that angle ABC is congruent to angle EBD because of the congruent supplements, meaning they're supplementary to the same thing, theorem. Fantastic. And that was my whole goal, could get to the point that those were congruent. All right, so you guys have this proof here to do, 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 which is very similar to the first proof we already did. And then we will come back and do this proof together. See you soon.